yesterday we left off at this point. Now to continue, what you can do is you can take S sub n as common, and you have 1 minus r left, and then you keep this the same. And afterwards, what you can do is take this to the other side, and you'll have S sub n is equal to this. And then you take A as common, and then you'll have this. So the formula for sum of geometric sequence will be S sub n is equal to 1 minus r to the power n times A divided by 1 minus r. So now I'll be showing you guys an example. Consider this geometric sequence: 2, 4, 8, 16. Now, and then say it ends here. And we've got to find the sum of the geometric sequence. You know that S sub n is equal to A times 1 minus r to the power of n divided by 1 minus r. You can do is take 2 as A minus r as 2, because there's common difference is 2. So what you do is 2 to the power of n, number of terms, 1, 2, 3, 4, 5. 1 minus 2. Which is then equal to 2 times 1 minus 2 to the power of 5, 2 to the 32, 2 to the 4, 4 to the 8, 8 to the 16, 2, then 1 minus 2 will be minus 1. So, now, which is equal to 2 times negative 31 divided by negative 1. Cancel out the negatives, which will give you 2 ones are 2, 3s are 6. This is the sum of 5 numbers in this geometric sequence. You can also try it this way. 16, 8, 4, and 2. That gives you 6, 14, 14 plus 6, 22. That's 5, 6, 62. There we go. We got it right. Now moving on to sum of geometric sequences when the number of terms are infinite. Say for example, you know that the sum of geometric sequence is equal to A times 1 minus r to the power of n. So if we had to find the sum to infinity, where n is equal to infinity, how would we do this? when, let's say when r will be equal to 1. Let's say when r will be equal to 1, so what will happen would be 1 would keep multiplying up to infinity, which is equal to 1, and we'll have a 0. That's not what you want. So let's say if it was let's say if r was greater than 1, sorry, greater than -1, and r was smaller than greater than -1 and smaller than 0. When r is greater than -1 and when r is smaller than 0, what you'll have is you have this. You have that as you have that as 1. Sorry, you have that as 0. So if you have, because r keeps multiplying, and then because it's such a small number, be basically negligible. Because it's basically negligible. Because okay, consider this one. Right, so it's greater than -1, smaller than 0. So consider this. Sorry, smaller than 0, so it'd be like -0.2, -0.3. Greater than -1, -0.5. Yeah, so when you multiply this, you'll get 0. You'll get 0 point something something something. So it's approximately 0, right? So what you can basically do is, because it's basically 0, so you can substitute in 0 instead of r to the power of n, right? 1 minus l, which is basically equal to a to the power of 1 divided by 1. So sum to infinity will be equal to a divided by 1 minus l. Because you see, when r is smaller than 0 but greater than -1, what will basically happen is that r to the power of n will be approximately 0. Because all the numbers between 0 and -1 is 0 point something something, -0 point something something. And when you multiply it again and again and again to infinity, it will be basically 0. So you can basically substitute this as 0. You have 1 minus 0 is equal to 1 times a is equal to a divided by 1 minus l. So thank you.